right, let's look at the quiz yourself questions for section 2.3. Let M be the set of all x's such that x is a letter in the word mathematics. And let B be the set of all y's such that y is a letter in the word beauty. Find M union B and N intersect B. Let's first look at what is M. M is, in list form, the letters M, A, T, H, E. We already have an M, A, T, I, C, S. And B is the set B, E, A, U, T, Y. So if M union B then we take all elements from M and all elements from B and we stick them in a list together. We don't have to include repetition, so we already have an E, we already have an A, we already have a T. Here we have the elements from A and then the unique elements from B. So we eliminated repetition. And if we wanted, we could order this list, for example, in alphabetical order. Now, if we intersected M and B, that's the list of what they have in common, right? We said they both have an A, we said they both have an E, and they both have a T. Quiz Yourself 13 reads, let U be the set A, C, E, G, I, K, M, O, Q, and let C be the set X of all x's such that X is a letter in the word game. So C is actually the set of G, A, M, and E. And to find C complement, what we'll do is we'll view C complement as U without C. So first we write down the U, A, C, E, and then we'll cross out any letters that are G, A, M, or E. So C complement is the set C, I, K, O, Q. So the letters in the universe that are not in C. And part B reads, let A be the set 1, 3, 4, 5, 6, and let B be the set 2, 3, 4, 6, 7, 8. Find B without A and A without B. B without A is to go into the set B. So you write down the first set and then remove any elements from A. So the 3 is in the A, the 4 is in the A, and the 6 is in the A. So B without A is 2, 7, 8. And A without B will be for us to go into the A set and then cross out anything we find in the B set. So remove the elements that belong in B. So A without B is the set that contains the 1, 5, and B without A is the set that contains the 2, 7, and 8. Quiz Yourself 14 reads, let A be the set 1, 2, 5, 7, 8, 9, and let B be the set 2, 3, 5, 6, 7. Let A and B be subsets of the universal set such that U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the following. So if we are looking at part A, in part A, we'll first have to find the intersection of A intersect B, and then the complement. So first we'll find A intersect B. So what does A and B have in common? That would be the 2, the 5, the 7. So first we have the intersection, 2, 5, 7, and then we can take the complement, right? The complement is to represent everything in U that's not in this intersection of A and B. So everything in U would be 1, not the 2, 3, 4, not the 5, 6, not the 7, 8, 9, and 10. Part B asks us to look at the complement of A, which is to look at U and remove the elements of A. So if we look at U and we remove the 1, the 2, we would have a 3, a 4, remove the 5, remove the 7, the 8, the 9, and we have the set 3, 4, 6, 10. If we look at the B complement, that's to look at U without B. U without B is representing the elements in U that are not in B. So the 1, not the 2 or the 3, but the 4, not the 5 or the 6, 7, but the 8, the 9, and the 10. And part D asks us to take the union of the two sets that we just took complements of. So A complement, union B complement. So if we union these two sets, right, we can at first just write everything down. But then by convention, we reorder and remove repetition. So 1, 3, 4, 6, 8, 9, and 10. And from here, we learn what's called the De Morgan's laws. And De Morgan's laws will show us what this fact right here, that when we intersect two sets and then take the complement, that's the same result as if we took the complements of those sets first and then found the union. So remembering what De Morgan's laws are and then using them, we have the one we saw above, right? So in the DM laws, we have that if we were to intersect two sets and then take the complement, that's the same thing as taking the complement of each set and unioning them. We can apply that to number 40. The second De Morgan's law says that if we intersect, if we union, we already did the intersect, if we union two sets and then take the complement, that's the same thing as taking the complement of each set and then intersecting. So we distribute the negation and flip the sign. So for number 39, we're going to use De Morgan's law to show whether or not these two given sets are equal. So using De Morgan's law, we distribute the negation. Oh, and flip the sign. Already messed it up. Oh, that was too much. Okay, let's do this one again. Distribute the negation. A union B intersect. A union B complement. Complemented is, according to De Morgan's law, distribute the negation, flip the sign. Now we have to clear up the fact that when you negate a negation, you get back the original. So A complement intersect B. And that is the second side. So yes, these are equal by De Morgan's law. Now, number 40, we're going to use the De Morgan's law from the last quiz yourself. Start with the left-hand side, apply De Morgan's, which is to say, distribute the negation, flip the operation. The complement of a complement is the set itself. And this is not the second side, right? So no, these are not equal.